Good morning to one and all. Today we are going to see about the speed control of DC shunt motor. First of all, you need to know the basics of your DC motors. As I said in a theory classes, types of DC motor. So first one is DC series motor, DC shunt motor, and DC compound motor. This DC shunt motor is a constant speed motor. Okay, so wherever the constant speed is necessary, say for example, if you want to carry one particle, say for example, one manufacturing industries are there, computer peripherals industries are there. There, they will be manufacturing some computer peripherals. So they need to carry that peripherals to one part to other part for a logistic or assembling part. So anything for that, you need this DC shunt motor, that is constant speed motor. Say, for example, DC series motor is the high torque motor in the sense, say, for example, uh, whichever is, say, for example, you're standing on your lift, five members standing on the lift. So approximate weight is 400 kilogram. 400 kilogram that five members has to carry to some 10th floor or 15th floor like that. So it needs some weight because that motor is already loaded with the weight. So it needs to carry that weight to that distance. So for carrying high torque is necessary. There, in that case, you are going for the DC series motor. Say, for example, in some industries, the weight of the machine will be more. The weight of the machine might be some 100 tons and all. So 100 tons, not even 1 ton. 1 ton means 100 kilogram. So 100 kilogram into 100. So that much tons. So the weight of the machine, one machine weight. So it needs high torque to there. If you connect the DC shunt motor, it won't carry because torque is not there. High torque is not there. Whereas your DC series motor having that high torque for carrying on. Then for moving, then you can go for the DC shunt motor. But you see, nowadays in the industries, majority of the industries, they are using the DC series motor and shunt motor. Shunt motor, I don't think they are using because DC shunt motor is replaced by your induction motors, induction motor. But DC series motor, they are using for carrying a high torque because your induction motor will not have this much torque for carrying. So DC series motor they are using and DC shunt motor is replaced by the induction motors. And also in your home you can't use DC motors. DC motors for pump motors you can't use DC motors. In that case you are using the AC motors, that is induction motors. Induction motors because the supply. First thing is supply. Supply means AC supply is universally applicable. So wherever you go, AC supply is universally applicable. So easy to use AC supply. For DC supply, you need a separate rectifier unit. So you can't take a DC power supply from your electricity board because they are providing only AC supplies. So DC supply you want to carry you want to install a separate rectifier unit, whereas that whatever the voltage range you want, the with that range you have to install a rectifier unit which converts your AC supply into DC supply. Then you can use your DC motors. But even though that is somewhat difficult because rectifier unit, you need to install a rectifier unit. And in DC motors, you see a brush, all DC motors have brushed motors, even though brushless motors are there. So for less range, you can use the brushless motor. Okay, say for example, in computers, you are using the DC motors. Inside the computers, one fan will be there, cooling fan will be there. So there, inside the laptops, you will be finding DC motors. So there you can use the DC motors. That is of very less range. There no brush. Okay, brushless DC motor. That application you can use. But if you take like more, say for example, load is more, so you need to pump some water. That case, you will require DC motors, shunt motors for with the brush motors. There brushless motors also it is there, but the efficiency you will not get. So you need some brush motor. And previously you see in mixer grinders, there will be a universal motor. We will call that as universal motor. So that universal motor will run both in AC supply and DC supply. So wherever you go, and say for example, you can also use that mixer grinders, mixies in your train also. But the thing is that it is not advisable to use in the train, because in the train you'll be having the sockets. So that it is a DC supply only. DC supply only, no, not a AC supply. So you can use your charges. So if you take your charges and you read the specification, that charges can work in both in AC supply and as well as the DC supply, your charges. Whereas you can't use your mixer grinders and all. You can use, but the thing is that the load will not support. You can't run that. Your speed of the mixer grinder will be very less if you run that. So that also. So and in the old type of mixer grinders, we are using this DC motors, old type. I'm telling about a 15 years old. So old, not latest one. Very old type. They are using inside the mixer grinders. They are using the DC motors. There will be a small conversion rectifier unit, and with the so there you will be using the brushes. And also the universal motor. So that is also universal motor. There you will be using the brushes. So previously you need to replace, if you are using a very old mixer grinders, you need to replace the brushes frequently. So that in that case, the universal motors. So nowadays, that universal motor also replaced by your AC motors, small AC motors, induction motors. So nowadays, no need of changing any brushes in your mixer grinders. And the thing is that in older motors, like in the industries also, and also in traction application, you are using this DC motors, DC series motor, and as well as DC shunt motors. Say for example, your memo trains will be there. Memo trains means some less distance trains will be there. Like 10 kilometers, 15 kilometers, 20 kilometers, around 30 kilometers. In memo trains, still they are using the DC motors only. So because that is old traction type, what you call engines. Okay. So if you want to replace, that will take more cost to replace every motors. So still they are running that old trains. So okay, by using the DC motors only. But if you take like a long express trains, previously, and telling about 10 years back, they are using this DC motors only. But now they have replaced everything with the AC supply, AC motors. So AC induction motors. Why? Because DC motors maintenance will be difficult, and the lifetime, and also brush you need to replace, and lifetime of the motors compared to, and cheap. Like AC induction motors are cheap compared to the DC motors. Say for example, the DC pump motors will be there. Sorry, AC pump motors will be there. You can get in the market for even 500 rupees also. AC induction motors. Whereas DC motors, minimum you need to spend around 2,000 rupees. 2,000 rupees starting price. Starting price. But induction motors, you see, within the 500 rupees also you can starting rate. I'm telling about starting rate. It leads goes up to 500, 1,000, 1,500, 2,000, 4,000, 5,000. So it depends on the range. But so minimum, so 0.5 HP motor with a, I think more than enough for your subs. So 0.5 HP motors you can get for 500 rupees also. That much cheap you can get that kind of motors, and also lifetime. Number of lifetime means number of operating hours. Number of operating hours of the motors also more when compared to the DC motors. So that's why many of the, but even though you need to study the because basic, if you study the construction of the DC motors, then your induction motors, like working of the induction motor, same thing. The thing is that this is DC, that is AC. That's all. The principle and all, everything is almost same. But you need to study. What you might have asked a question, why we need to study the speed control of DC motors. As I said, in few industries, still they are using DC shunt motor for their application. Because the thing is that they have already installed that motors, DC shunt motors. If you want to replace every motor, say for example, they have some 200 motors, DC shunt motors. If you want to replace every motors, they need to spend a more amount. So still they are running by DC shunt motors only. You need to replace the brushes frequently. That is the only limitations of the DC and supply. Supply rectifier unit you need to get. So rectifier unit that cost some. It depends on the application. So the rectifier cost you need to pay. That's all. But the still you see the laptops in your television, LED TVs, and your computers. So everything you'll be finding, if you open and see, you'll be finding small cooling fans and all there. So that there, and not only cooling fans, there are some applications inside they're using the DC motors, small motors. It is the cooling. So in all the applications, many applications in electronics, you'll be finding this kind of DC motor. So here you are going to study the speed variations of DC motors by using the armature voltage control method, and as well as the field control method or flux control method. Here, the speed of the shunt motor is given by N is equal to this K into V minus IA into R. So IA into RA is nothing but your current and armature resistance. Okay, so the speed of the shunt motor may be made by varying the armature resistance, flux, and as well as the applied voltage. The armature voltage control is based on the fact by varying the voltage available across the armature and the speed and the motor speed can be changed. So this can be easily done by inserting a variable resistance in series with the armature. So that we are going to see. Next, due to the voltage drop in the resistance, the back EMF reduces under the speed decreases. By changing the value of resistance, different speeds can be obtained. So by varying this like a rheostat, armature resistance, and as well as the field resistance, that is a field resistance, the flux, we can change the different speeds. So we want over speed or under speed. So that we can easily do by with the thing. With this control, then the flux should be maintained constant. Keeping the armature voltage constant and by varying the flux, the motor speed can be changed. The flux can be varied by changing the field current. The rheostat field can be used to reduce the field current, and hence the flux. So consequently, the motor speed is increased. So here, the practical application where this change in the speed happens. Say, for example, you're manufacturing some computer peripherals. Okay, so for in from one place to other speed, you need to carry that. So as I said, that load might be constant because you have seen some conveyor belts. Say for example, coal in a coal power station, in coal thermal power station, you have to carry the coal from one place to another place. So one place to another place means a coal yard might be some 2 kilometers or 3 kilometers apart. Your boiler station might be some 3 kilometers up. So there the coal has to carry from there to here. So sometimes you need more coal, sometimes you need less coal. Depends on the the load. Sometimes you want more coal and some. So that time, so more coal you need, and you need to increase the speed of the conveyor. You need to increase the speed of the conveyor belt. So there you can utilize this field control method to vary the speed. So for example, 1500 RPM is the some constant speed, for example. So you need to increase the speed by some 1600 RPM because we need more coal, more coal. So that this if you vary this like a field control method, so automatically the speed of the machine gets varied. So the coal input to the boiler also will be increased. Not only coal, say for example, whatever the product that conveyor belt is carrying. So say for example, the loading should be in the logistic. Okay, you completed all the things. You need the loading fast. So in that time, you need the conveyor belt speed to be the fast. So there also you can increase the speed, and sometimes the load should be sorry. You need to fill the logistic very slow because you need to deliver tomorrow or day after tomorrow like that. So in that loading point, you need some slow. So there you can decrease the speed of that particular motor. So that also possible. These are some of the practical applications I'm telling. Next, coming to the circuit diagram. Circuit diagram is very simple, as I explained in the previous class itself. Yeah. So this is the circuit diagram for the speed control of the DC motor. So here, positive and negative turn. So always you have to remember while drawing the circuit diagram, positive and negative terminal. If wrongly, if you mention this 230-volt AC supply here, then entire concept is wrong, and the entire circuit is wrong. Okay, the whole circuit is itself, it is wrong. So you need to be very, very careful while drawing the circuit, whether it is DC supply or AC supply. So this is the DC shunt motor. So definitely you need DC supply only, 230-volt DC supply only. So always while marking the you're drawing the circuit diagram, you should mention whether it is DC supply or AC supply, and also phase or neutral, or say for example, DC supply means positive terminal and negative terminal. That you need to mention very correctly. Sometimes what you'll do, so you'll draw the whole circuit, everything will be correct. So you will not mention this positive negative terminal. Here you will not mention what is the voltage supply. Here we will not mention whether it is AC or DC. In that time also your circuit is, the whole circuit is wrong. Okay, you can't claim like I've done everything correct. Yeah, my marks is reduced. Like you can't claim. So these are the some simple blunder mistakes. Blunder mistakes that many students will do. But the thing is that you guys don't do this small mistake also. That's what I'm repeatedly telling. Next is that is connected where like a DPST switch. So DPST switch, what is DPST switch? Double pole, single throw. Okay, double pole, single throw. So two poles are there, only single throw, only one throw. So if you see in the laboratory, Only one switch is there and a fuse points also there. Here there are two rheostat is there. So one is for field, one another is for armature. So there are two windings, field windings and others are armature windings. So this field windings you will be seeing that will be connected in the like panel board will be there. Na? So there you will be having the two terminals like a plus Z minus Z. Okay, so this is the field winding. So field winding. So you may have one question. Where can we found this field winding? So field winding is there inside the machine. So what in laboratory what we'll do is we'll take out that terminal outside. We'll take out the field winding to terminal outside and we'll connect it to the panel board so that you can easily connect. That's what, but a field winding there in the inside the machine. But we have taken that field winding connection outside with the plus Z and minus Z. So here you'll be having the rheostat of 290 ohms and 2.8 amperes, 290 ohms and 2.8 amperes, and having the ammeter of ammeter range of here positive and here negative. So here ammeter range is 0 to 2 amperes. So here is MC, moving coil. Okay, so always all machines, all DC machines have moving coil meters, whereas all AC machines you have moving ion meters, moving coil meters. Suppose wrongly, without seeing what we'll do sometimes, we'll connect instead of moving coil meters, we'll connect moving ion meters. We'll take AC meters and connect in DC supply. So what happens? Your pointer will not move, and the pointer will be always in the vibrating mode. It will not move at all. So it will be in standstill. Okay, sometimes your meter will have some sound. Okay, your coil gets heated up if you connect like this wrongly. Like that, many things may happen. So always you have to remember it will be in the moving coil or moving ion. So we'll see, we'll try to make some videos of the working of the machines in the forthcoming classes. Here you'll be having the armature rheostat. Armature rheostat, what is the range of the armature? 100 ohms and 5 amperes. So here field rheostat 290 ohms and 2.8 amps. So here you see the machine. So always while drawing the DC machine, any DC machines, you'll be mentioning M. You need to mention as here bar after M, M bar. Like so, why this mention? This is the notation for mentioning the DC motors. This is the single line diagram. Is the say for example, this is the single line diagram. Single line diagram means so only you'll be having sorry, this is a circuit diagram representation. So in the single line diagram, we'll mention the DC machine like this. M, you need to underline. You need to make a small underline. So it is mentioned like this is the DC machine line. So here you will be having two terminals like plus A and minus A. So this armature winding also inside the motor only. So you'll be not seeing outside. But what we'll do is in the laboratory, we'll take the two armature connections outside and we'll mention as 2 points. Okay, as plus A and minus A. Like so next for measuring the 230 volts, we are connecting 0 to 300 volts voltmeter. But in laboratory, you'll be having 150 volts, 300 volts, 600 volts like that. So for measuring 230 volts DC supply, we are going for 0 to 300 volts voltmeter. And that also voltmeter, always it will be connected across. That is connected in the parallel with the any say for example for measuring the load voltage of this motor, we are connecting across this terminals, and here The ammeter always connected in the series. So you may have one question. So this is not in series. This is in parallel only. No. So if you take this part of the circuit alone, this part of the circuit alone, it is connected in the series. This part of the circuit, it is connected in the series. That is ammeter of the ammeter is connected in the series with the circuit. Okay, so this is all about your circuit diagram. What about the working? What about the working? How it will work? So first, what we'll do, we'll switch on the DC supply. We'll give the 230 volts DC supply and with the DPST switch and with the fuse. So here the supply you will be connecting the supply. So first, what we'll do is this armature rheostat you have to put in the maximum position because maximum position means with the resistance, with all the resistance, this armature rheostat will be in the maximum position and the field rheostat will be in the minimum position. You'll be having the two rheostat. So first, this armature, as I said, armature rheostat in the maximum position and the field rheostat in the minimum position. So why it is in the maximum position? If it is in the minimum position, what happens? Say, for example, if you are starting the armature reactance in the minimum position, you are starting the motor. Wrongly, you are starting the motor. Then your motor will run at the n speed. N speed means the rating of the machine is 1500 RPM. Say, for example, this field rheostat also, instead of minimum position, so what you are doing is you are wrongly connecting without this is open. Say, for example, this field is open. So your motor will run at n speed. Your motor will run at more speed. In that scenario, there will be a possibility because, say, for example, motor will run at n speed means double the times the motor will run. So the thing is that it will spoil the life of the motor. It will spoil the life of the motor, and also say I said no, the motor will run at n speed. So that should not happen. So always remember, like you need to put this armature rheostat in the maximum position. So while starting the motor will run at, say, for example, rated speed of the motor is 1500 motor. The motor will run at around 1100 motor initially. If what you will do is you will cut the armature rheostat slowly. So the speed of the motor will increase. The speed of the motor will increase up to 1400 plus RPM. So again, what you will do is you just move this field rheostat. Automatically, the motor will run at 1500 RPM. So your motor will be running at 1500 RPM simply. So then comes this observation. So here what we are doing is we are doing the two methods. One is field control method and another one is armature voltage control method. Field current control method and armature voltage control method. For field current control method, what we are doing is we are making the motor to run at maximum speed. Maximum speed means above rated speed. Rated speed is 1500 RPM. So above rated speed means we are making the motor to run at 1500, 1600, 1700 up to 1800 like that. We are making the same motor to run at over speed. Okay, as I said, no, in that application, say, for example, your conveyor belt speed has to increase sometimes. In the logistic, you need to load fast. So in that time, your conveyor belt should be, the speed of the conveyor belt should be, the speed should be increased. So in that condition, what we are doing is we are just varying this armature rheostat, okay, sorry, field rheostat, so that automatically the speed of the motor will be going high. Speed of the motor will be going high to 1600 RPM, 1700, 1800 RPM, and the corresponding readings we are noting down. Similarly, here you see the armature voltage control method. Here what we are doing is, here again you are reducing the field, reducing this field winding, that is field rheostat to the minimum position, and the armature rheostat to the maximum position. So automatically what happens is your speed of the motor will decrease. If you vary this rheostat, this armature rheostat, automatically your speed of the rheostat will be going down. Say, for example, in the terms of 1500, 1400, 1300, 1200, like that, automatically your speed of the armature voltage, speed of the this armature voltage control, automatically the speed will, and the corresponding voltage should be noted down. That's all. Next, coming to the calculation, we are calculating the efficiency. Yeah, speed control of the this shunt motor. Yeah. So here you are drawing the by noting down all the readings. Here you are drawing the speed versus voltage. Okay, performance characteristics, speed versus voltage with respect to armature voltage, how the speed will vary. Next, with respect to field current, how the speed will be vary. So with respect to armature voltage, the speed will be increasing. The speed will be in the increasing manner. With respect to field current, the speed you see with the respect to speed, it is initially it is high and it is coming down. As I said, initially it is 1500 and it is slowly it is coming down to 1300, 1200, 1100, 1000 like that. So with respect to field current also with respect to field current increasing, or automatically the speed of the machine will be decreasing. So this is the conclusion. The speed variations of the DC shunt motor by varying the armature voltage control and as well as the field current control method is studied. Like that, you need to conclude this experiment.